Okay, so today we're going to finish up that list of triangle congruence theorems and postulates with the angle side angle and angle side congruence theorems. The only vocabulary today for is a flow proof, and this is just a different way to write a proof than the way we have. We'll do an example during the lesson so you'll see how it's laid out. What the flow proof is good for is showing kind of how the logic all comes together. Alright, so postulate 21, angle side angle congruence postulate. Now, just like the side angle side, the order that the letters are written in matters. So this is two angles and the side between them. So on our picture here, if angle A is congruent to angle D, angle C is congruent to angle F. Those are our two angles, or two pairs of angles. Okay, and then the side between them, AC is congruent to segment DF. So then we've got our two congruent sides between those two congruent angles. We can then say that triangle ABC is congruent to triangle DEF. The angle side congruence theorem. Alright, this is also two angles and a side, but it's not the side between. It's a side that's not between, but still the same corresponding one. So if we have angle A is congruent to angle D, angle C is congruent to angle F, and here's where you need to be careful. Segment BC is congruent to segment EF. Now, if you look at segment BC, that is the one off of where we have the angle marked with two arcs. So this also has to be the side that's off of the angle with two arcs. That is segment EF. Okay? If we had segment ED, it wouldn't work because it's not the corresponding side. So put that together and we have triangle ABC is congruent to triangle DEF. And again, it's still important that our corresponding parts line up. So just to restate that, when you have angle side, okay, make sure that that side is the corresponding one. Okay, so identify congruent triangles here. Let's go through. If we look at A, what we can gather from the picture that's not already marked is that our two vertical angles here are congruent. Still, there is no angle. We don't know any of the sides. So because no sides are known, we can't say that's congruent. Now, if we look at B, we've got the two angles marked, and they also share this side, so we know that's congruent. And if I look going around, it's angle side, congruent to angle side. So, two pairs of angles and a non-included pair of sides are congruent. The triangles are congruent by angle side. Now, if we look at the last one here, we've got two angles marked, two sides marked, and we know that the vertical angles are congruent. So two pairs of angles and their included sides, that's included sides there, are congruent. So this is congruent by angle side angle. Again, the order that the parts are in matters. This one, the side is between the two angles. Okay, go ahead and do checkpoints 1 and 2. A hint for checkpoint number 1 is draw the two triangles separate from each other and then mark all the parts congruent. It'll be a little bit easier to see. So again, draw them separately and mark all the parts congruent. So pause the video, work out those two, then come back for the answers. Okay, so here's checkpoint number 1. Now, if you take that hint and draw the two triangles separately, triangle STW is one of your two triangles. So here's triangle STW, and over here, we'll draw a triangle VWT. Okay, so the green and the orange triangles are what you're trying to show are congruent. So here's triangle VWT. Now, if we mark our congruent stuff, we know that angle S here is a 60-degree angle. Angle V is a 60-degree angle. Angle T is a right angle. Angle W on this triangle is a right angle. Now, the other stuff that we know is congruent is segment TW is congruent to segment TW by the reflexive property. So looking at our triangles, we have got angle, angle, side congruent to angle, angle, side. And double check, the side is next to the right angle, so it is the corresponding one. So yes, we can say that triangle STW is congruent to triangle VWT by angle, angle, side. For this one, the triangles are already separate. The thing we know is that TW is congruent to itself. So here we've got angle, side, angle, congruent to angle, side, angle. So our triangles STW is congruent to triangle VWT by angle, side, angle. Okay, here's our flow proof. And it looks like just kind of a mess here. So let me point out some things. Now, here we've got our given, all right, and our prove statement. So what we do is we take each of those givens and where it leads us to finally showing that the two triangles we want. CBF, so we want to show this green triangle is congruent to triangle CDF, the red one here. Okay, so we can start out with our givens. Now, the first given is angle 1 is congruent to angle 4. We've got that statement here, and the reason for that is given. So what you're doing is taking your statements, putting them in the bubbles, the reason, writing it down below it. Now, if we look, we know that angles 1 and 2 are supplementary, okay, because they form a linear pair. And we know that angle 3 and 4 are supplementary, again, because they are a linear pair. So it says definition of supplementary angles, but it's actually linear pairs are supplementary. Okay. So linear pairs are supplementary. Now, if we look at both of those two things together, 1 and 4 are congruent, 2 and 3 are supplementary to them. The congruent supplements theorem tells us that angle 2 is congruent to angle 3 because they are both supplementary to congruent angles. Okay, so let's mark that on our picture. Angle 2 is congruent to angle 3. That's our first line of reasoning there. Now, the next one is we know that segment CF bisects angle ACE. So there is our second given. All right. Now, bisect means it cuts it in half. So we can say angle ACF is congruent to angle ECF. And the reason for that is definition of angle bisector. So let's mark our picture. So now we've got our two angles. If you remember from our list of triangle congruence theorems, the ones with two angles are angle side angle or angle angle side. I don't see how we're going to show the two included sides are congruent, but if we look at the two non-included sides, okay, I'll use black for this here, they share that side. So we can say CF is congruent to CF by the reflexive property. So now we've got our two angles, the non-included side. So the triangles are congruent, and that's supposed to be triangle CBF is congruent to triangle CDF by angle, angle, side. Okay, moving on to checkpoint number 3. Don't follow the instructions that are in the book. What I would like you guys to do is rewrite example 2 as a 2-column proof. Okay, so go ahead and do that now, please. Okay, so here's the beginning of our proof. I've tried to color code this a little bit for you. If we look at the first given, that angle 1 is congruent to angle 4, we can tell we've got our supplementary pairs, the linear pairs. That leads us to angle 2 is congruent to angle 3. That's the first angles that are in the triangle that we want. Next, we're given that CF bisects angle ACE. That gives us angle ACF is congruent to angle ECF. That's our second pair of angles. Now, once we know 2 pairs of angles, we need a side. The side that we can get was that segment CF is congruent to segment CF. That segment is in both triangles, so we say it's congruent to itself by the reflexive property. And that's our side. That side is non-included, so we can come to the conclusion that triangle CBF is congruent to triangle CDF, and the reason is angle, angle, side. So this proof right here is the exact same thing that's above it in example 2. This is written as a 2-column. Example 2 is written as a flow proof. All right, choose a postulate or theorem. So if we go through this one, basically what we've got is this picture here. Could you figure out where the flagpole is? Yes, there is, because the locations of you, your friend, and the flag forms a triangle. The measures of 2 angles and an included side are known. So, by the angle-side-angle congruence theorem, all triangles with these measures are congruent. So the triangle formed is unique, and the flag location is given by the third vertex. This is actually kind of a silly example. There are some really good real-world examples of this, and tomorrow in class when we go over the notes, I'll go over 1 or 2 of those with you, including some that I've actually used in the real world myself. So that sums it up for this one. Like I said, this is the end of our triangle congruence theorems. So today we learned angle, angle, side, and angle, side, angle. Okay. To finish this off, I wanted to go over some things. Some books have some other theorems that are not on this list, but we have covered them. Okay, some have what's called leg-leg. Now, if you look at a right triangle here, and you've got a leg and a leg congruent, you see that's really just a special case of side, angle, side. So we don't need this leg-leg. We can just always use side, angle, side. Now, another one that comes up is leg angle. Leg angle, if we look at this first picture here, you can see is either a special case of angle, side, angle, so we wouldn't need leg angle in that case, or if we look at the second one, it's an example of angle, angle, side. Again, we've got that, so we don't need that extra theorem. Now, there's one other one that we've already seen the special case of, and that's this one, hypotenuse leg. Now, if you look at what that would be if this weren't a right angle and it were just a regular one, what we've got is our angle, side, side. And like we said before, that one does not work. You saw counterexamples of that in the last one. So hypotenuse leg is a special case, but it is a special case that works. So that's why that's kind of the odd one out. Most of the other ones, the special cases, we've got the general ones. In this one, we want to keep the special case because the general one doesn't work. So that's it. I will see you guys tomorrow in class.